Okay, and I appreciate that lead-in, Josh, to the avian element. Our next speaker is going to be talking on that subject. Andy Leidhoff is a native of Germany and a USU alum, and he's currently a visiting research scientist at Utah State University. And he's going to be talking about avian response to frost damage aspen in the Wasatch Mountains of northern Utah. So, Andy?
Well, first of all, thanks very much for being here. I told Paul earlier, together with the previous speaker, I feel a little bit like I'm sort of the wildlife affirmative action guy here. But I do appreciate the turnout for this late in the meeting and in the afternoon. I am going to try to keep it fairly short, and I'm not really here to give you a big avian ecology talk. I think that's maybe for a different audience. What I do want to share with you is a little bit of the work that we've done here in the last couple of years. I should at this point also acknowledge my co-author and good friend Ron Ryle, who cannot be here with us today, unfortunately. But he and I have been working on avian ecology in aspen for the last 2 or 3 years, so we're still kind of very preliminary in this program. We've looked at primarily the aspen conifer situation, trying to get a handle on how avian communities differ between these two extremes and also in the integrated communities that we're seeing, trying to sort of get an avian ecological perspective on the aspen restoration issue that's going on up there. And I think Josh Leffler has probably talked about a little bit about the vegetation manipulations that we're doing up there. So that kind of ties in with that. What I've kind of done for the last 10 years primarily is look at the effects of large-scale natural disturbances in avian communities. And I think that's something that most of us are sort of intuitively familiar with, because it sort of gets at this idea of large-scale vegetation changes, both in composition and structure, associated successional changes that track all the way through the animal communities, whether it's small mammals or birds, which is an organism that I've sort of been working with for the last 10, 15 years. This is sort of a good example right here of what we're talking about, where we're starting with sort of an old field succession, as we might see it in the Carolina Piedmont or in the Gulf Coastal Plain. There we go. Where we're basically looking at, starting with a fairly, community of fairly low structural complexity, a bare field that then changes into grassland. We're starting to get some woody component, and then we're seeing sort of that succession take off with a succession of woody species. I think that's fairly intuitive, and what we tend to see is sort of this sort of coming in and blinking out of different avian species. That's not really so much what I want to focus on today, although we also do see that here in the Intermountain West, where I've been working with primarily Gamble oak. This is another example right here, a slightly larger component of species. But again, this idea that we have these species that are sort of tied to certain successional stages in this game. Some that that have fairly low abundance, but then sort of pick up abundance as the habitat becomes more favorable for them. We have some of these generalists that are sort of around pretty much throughout the entire successional sequence. And that's one way to look at these disturbances. And there's a huge literature out on this sort of very typical disturbance ecology. I've actually, as part of my PhD, I've done sort of a very large literature review and meta-analysis, particularly of fire effects on avian communities. And I can tell you there's something like, in the worldwide literature, there's something like 500 plus studies that look at the effects of fire on avian communities. What hasn't really been looked at so much are sort of what I would term transitory disturbances. And those are the disturbances that may not have a very long longevity, that may be fairly low in impact, that don't result in sort of this resetting of vegetation conditions, but that are probably a lot more subtle. And if you look in the literature, particularly climatic factors, if you look in the literature with these sort of things, there really isn't a lot that's out there. When we started doing our work at Deseret, we established an avian monitoring protocol that allowed us to sort of track the avian community through time in the Montana aspen up here in the Wasatch Mountains of northern Utah. And one thing that we sort of stumbled upon last year was a bit of an odd climatic event that really kind of got us thinking about these transitory disturbances, kind of coming away from these sort of large-scale issues to more these sort of what we may otherwise consider to be negligible type disturbances. This right here is a long-term, about a 30-year data set of daily spatial normals of temperature, both daily max, daily min, and then this would be the average for the study area that we were looking at. What happened in mid-May, early May of last year, what I've done here is actually overlay the actual data from our study site, which is the Lightning Ridge NRCS SNOWTEL data, for about a 3-month period, a little bit over a 3-month period. And what I want to sort of draw your attention to are some climatic events that took place in May that really sort of started us thinking about this whole issue of these transitory disturbances. And what we got was in the second week of May, for about a 2-week period, we had this prolonged period of quite a bit warmer than normal temperatures. Now, sort of this really early warming period. And if you look right here, these are the temperatures. You can see that both the max temperature, this would be the average, and here is the min. All of those are quite a bit above what the daily station normals are for that 30-year period that we have data for. What happened after that was not so much an unusual event, and that was a late frost. We do get those here, and those are not so much what caught our attention. It was really this warming period that preceded that frost. What happened during that warming period was that a lot of the aspen up in our study site started to leaf out. We started to get that first flush of leaves, and it was quite a bit earlier than what we had seen in previous years. What that late frost then did, when it came around 2 weeks later, was it essentially completely killed that first flush of leaves. And for the next almost month and a half, we were up there and we just kept driving around. Our jaws just dropped when we looked at the place. It looked like it had been nuked, and it looked like somebody had sprayed some nasty stuff out there because it looked like it was otherworldly. It didn't look like the kind of aspen that we've come to know up there. And that's a beautiful place if you haven't had a chance to go up there. So the more we started seeing this, the more we started thinking about, well, what are the birds going to do? Because they were within a couple of weeks of arriving on site from their migration. They generally start, sort of at the lower elevations, and they kind of, as the snow recedes, they'll move their way up in the aspen. So we really started thinking about what's going to happen. Well, we had actually just finished up with some preliminary avian monitoring. We really weren't planning on doing much work last year. But when we saw this, we said, well, let's see if we can do something here. We've got some data from the previous years prior to this event. And here we have an opportunity to maybe come back and collect some more data and see if we can track a little bit what the effect of this disturbance might be on the avian community. Again, this here is our study area. So you can see we've got essentially Deseret Land and Livestock Company. That is where I think Josh Leffler, you talked a little bit about the vegetation manipulation we're doing up there. We also kind of spilled over a little bit on the adjacent Wasatch Cache National Forest. Both of these are located in the Monte Cristo Range of the Wasatch Mountains, which is basically just east of Ogden in Cache and Weaver counties in northern Utah. This is the avian monitoring program we put into place starting in 2005. We managed to snag a small startup grant from Utah State University that allowed us to kind of pursue this, and that's what this dates back to. What we did at the time, and this is just the aspen component, we also established census stations in the conifer and in the intergrade communities, but obviously here we're just talking about the aspen. We had 42 permanent 50-meter radius circular plots that were established along transects, about 320 meters apart. We used pretty standard survey protocols from Rafadal, and our censuses, because of the high elevation, were fairly late in the year, early to mid-July, between 6:30 and 10:30 in the morning. We did counts for about 5 minutes. So that's kind of our methodology. Whenever you're doing a study where you're looking at what we didn't really know at the point in time, but where you're trying to look at the effect of a disturbance on a select group of plots, and you're trying to compare that to some kind of a reference condition, you're really concerned with how comparable the plots you're actually monitoring are. And one of the things that we did here sort of post hoc is we actually looked at to see how comparable these plots were, how homogeneous were these 42 census stations. And they were definitely comparable with respect to topography. They were all located on ridge lines or on sort of plateaus with fairly level topography. Elevation-wise, they were all in a fairly narrow range of elevations with a maximum or a range of a little bit over 100 meters, a little bit under 100 meters, and it's, you see the standard deviation is fairly small. So there's very little variation among the elevation of these plots, and they were all dominated by quaking aspen. Now there were some differences probably with respect to the understory. We had some aspen stands that were a little more herb dominated in the understory, others where we had a little bit more of the shrub component, snowberry, that sort of thing. And that does tend to sort of have effects at the species level when you're looking at what type of avian species tend to use these sites. But at the community level, which is sort of what I'm trying to take you through here today, we really felt that probably didn't have too many consequences for us. What we did after the initial sort of that initial frost event, we let a couple of weeks go by. We came back in late June, early July, and we actually looked at what had changed in that time period. And we saw that a lot of the trees that had been hit very hard by the frost had kind of tried to put out a second flush of leaves, but we definitely noticed the sort of the lingering of that effect. And based on that, just visually looking at foliage condition and status, we sort of tried to classify the aspen into aspen that had been hit very hard, that had probably already more or less fully leafed out when the frost hit, aspen that had showed sort of moderate signs of damage, and then aspen that maybe hadn't even started leafing out at the time that frost hit, and as a result showed no or just very low evidence of frost damage. And so based on that, we took our 42 census stations and classified the vegetation, the aspen vegetation in each of these plots based on that visual inspection as either severe, moderate, or low damage due to frost. And once we had completed that, we found that we ended up with about 10 plots that we classified as no or low damage, 19 plots that showed moderate signs of frost damage, and 13 plots that showed severe signs of frost damage. Now, these are not great sample sizes in the grand scheme of things. When you're dealing with natural disturbance, you're sort of dealing, or you're working with the hand that you're dealt. And we felt at least confident to take a very, very initial look at what some of the effects might be as a result of this disturbance. The idea behind all of this is one that you may know as BACHI, or before-after control impact. It's also been referred to as intervention analysis. Basically, the idea that you're looking at a disturbance that occurs at some point in time, and you're looking back into time. In our case, we had 2005, 2006 data that was collected pre-disturbance. You're looking at sites that either experienced the disturbance versus sites that didn't experience the disturbance, and then you're trying to post-disturbance pick up that change. Now, in our case, we didn't have sites that were affected versus those that were unaffected, but rather we classified sites according to these three categories of severity of damage. So that's really the only difference from this diagram right here, but I think that kind of gets the point across. Our analysis was fairly straightforward. Again, I'm not going to try to throw any heavy statistics around here. It was a fairly straightforward analysis. We were just looking at a two-way factorial split plot design where we used the frost damage level, this moderate, low, severe, as our whole plot factor, and then our subplot factor was the year of observation, so 2005, 2006, 2007. And again, not trying to turn this really into an avian ecology talk, we try to keep the response variables fairly simple and fairly intuitive, and at the community level, where we can really start to see that overall effect. And so we're looking at things like species richness, species diversity, evenness, and total abundance. Analysis was basically just an ANOVA, and then we looked, of course, at the pairwise comparisons using Tukey's studentized range test. And this is what we found, just short and sweet. This here is species richness over that 3-year period, again, keeping in mind that 2007 is when that late frost, well, really not the late frost, but the frost following that early warming period occurred. And what we noticed, and these trends are not necessarily significant, but we didn't really find a year effect. So there really was no difference in average species richness across these 42 plots as we go from 2005 into 2006 to 2007. There's a slightly increasing trend if you collapse these 3 observations into an average. And that is actually makes sense, because when we look at 2005 was the first year that we were coming out of a 5-year drought. And 2005 was actually an average moisture year. 2006 was above average. So we actually kind of expected, starting our monitoring program right at the end of a 5-year drought, that we'd probably start to see some increasing trends in avian abundance, in species richness, and so forth. But these are not necessarily significant trends. What I really want to point out, and although this trend is not significant, I think you still sort of get a hint of an idea, of a trend there, is that that we're starting out with low, moderate, and severely impacted plots pre-disturbance that really aren't all that different with respect to species richness, and that once we go into the post-disturbance year, we're actually seeing sort of a fanning out according to the severity of the impact, such that the plots that had very low frost damage had the highest species richness, those with moderate were kind of in the middle, and those with severe were kind of at the bottom of that. Again, not significant, but given our small sample size, I mean, we're lucky to have gotten this trend. We saw kind of the same thing in species diversity, which of course has species richness as a component of it, so that's not terribly surprising. What's kind of interesting is what we found with species evenness, so the idea that how evenly are individuals distributed among participant species in a community. And what we found here was actually a significant trend over time, such that post-disturbance we ended up with a much less even avian community. The way birds were distributed across the landscape was much more clustered, much less evenly than they had been in previous year. And again, that's something that we could think about as making sense, given that we've had this disturbance event. Where things really get kind of interesting is when we look at total abundance. And again, this is not trying to break things into individual species responses. It makes sense that when you have a disturbance occurring, there are always going to be species that are favored by the effects of that disturbance. There are other species that are negatively advantaged. What we're trying to do here is look at all birds across all species to simply get a feel for what happened at the community level. And what we find is that really no significant difference across years, so year was not significant, with the total abundance on average being about the same over that 3-year period, but a fairly significant breaking out of that abundance across these 3 different categories of frost severity, such that plots that had low frost damage had the highest total abundance of birds. Plots of intermediate damage had sort of intermediate total abundance, and those with severe damage had the lowest abundance. And those were significant differences. So it was really kind of interesting, because ultimately what that told us was that when you look at the landscape level, the post-disturbance avian community really wasn't all that different from the avian community that had been on that site the previous year, discounting sort of a slight increasing trend that we attribute more to that community recovering from the 5-year drought that preceded our 3-year observation window. What did change, though, was that there was a pronounced shift in how individuals of birds distributed themselves across the landscape, such that birds were favoring stands that had low levels of frost damage over those that had either intermediate or high levels of frost damage. So essentially, these birds are packing into these sites that had very low impact compared to some of these other areas, which is really kind of an interesting perspective when you think about what does that have to say about how birds select their habitat, but also about what the importance of, for example, a genetically diverse aspen landscape might be for things like wildlife. When we think about a hierarchical view of habitat selection, this is sort of more of an avian ecological perspective, so I don't want to spend too much time on that. But essentially, what this sort of indicates is that when a species arrives at a site, it makes this sort of sequential set of decisions about where it's going to set up a territory. And the idea here is that each decision that is made sort of constrains the pool of possible choices that can be made after the fact. So that when a bird arrives at a place that has been impacted by, say, a frost, and all of a sudden finds habitat conditions that may not be entirely suitable, there are really 2 choices that individual can make. Can say, well, I'm either going to pick up and leave, I'm going to go somewhere else, or I'm going to try to make do locally. And a hierarchical view would sort of favor that second idea, that a species arrives on the site, makes a set of decisions in the Monte Cristo Range or the Wasatch Mountains, and then has to sort of try to find a suitable area within which it can set up its home range and its territory. The other aspect about this that I think is kind of interesting is that even a transitory disturbance, something that we tend to not think about as something of great significance, can have pretty significant impacts on the avian community in montane aspen. And what I'm really kind of curious about is, what does this have to say about how important it may be to have a diversity of genotypes out on that landscape, to have aspen that may be more resilient to frost as opposed to aspen that is more susceptible, to have aspen that is more likely to put out a first leaf flush fairly early in the year as opposed to aspen that does so quite a bit later. By sort of having that reservoir of different aspen genome and phenotypes, we may be introducing some buffering into that landscape that not just the aspen benefits from, but also wildlife such as bird species, because it allows them some kind of a refuge that they can sort of rely on whenever these kind of events happen. One thing that I kind of want to throw in here, because it's been brought up by previous other speakers, is sort of climate change. Is it more likely that these sort of free climatic events are going to become more common as we're seeing the effects of climate change on the landscape? And what does that have to say about the importance of aspen genetic diversity? Even if you're not necessarily into birds like I am, just from the perspective of aspen, that might be kind of an important consideration. This is a very preliminary and very small data set. And the reason I brought it here was because I've got here a captive audience of people that study aspen. And whenever you're dealing with a natural disturbance that sort of relies on these anecdotal little bits and pieces of evidence, this is not a nice, clean experimental design where we can go out and we can defoliate at the landscape level aspen and see what the effect is going to be. This is a natural experiment. This is sort of where we're dealing with what we're dealt, the cards that we're dealt. So it's always going to be very anecdotal, but what I'd really like to sort of throw out there is for you to sort of, when you go back to your national forests and the areas, your states where you're looking at aspen, is to sort of keep an eye out for these sort of events. And if you know somebody that has an interest in birds locally, maybe kind of give them a nudge and say, hey, we've had this kind of freak event. You might want to maybe go out there and collect some data and kind of see if you can show some sort of effect. Or at least, give us a call or send us an email if you notice one of these events, because it will give us the opportunity to go out there and hopefully collect a little bit more data and try to firm this up. So definitely there's a big need for additional observations. I'd also like to throw out there that, again, this is, at this point, just pure monitoring and abundance data. Obviously, we've been interested to find out what does this do to avian productivity. What does this do to predation? What does this do to the overwinter survival of adults? If we're taking a whole bunch of individuals and we're packing them into these remaining sites that have had very low impact, even for just a season, we're looking at probably a scarcity of food resources. We're looking at increased competition that may affect the number of young that are fledged off of some of these nests. It may affect the number of clutches that some of these birds are able to bring off. So we may see sort of a more of a longevity in that effect in subsequent years if we were able to look at things such as productivity and overwinter survival. Something that currently we're trying to get the funding for, but we're not really in a position yet to do that. So again, that's something I kind of want to throw out there. Monitoring, of course, is great, but ideally those are some of the things that we'd really like to get at, because that's really where the interesting data are. So again, I try to keep it fairly brief and fairly simple. It's not a complicated story. It's really more sort of the beginning of what I think might be kind of an interesting line of research. So I just kind of wanted to throw that out there for food for thought. I do want to acknowledge our funding agencies, USU through a Community University Research Initiative in 2006, and the USDA NRI grant, and I'm currently housed at the USGS Utah Crawford Fish and Wildlife Research Unit, so I want to acknowledge them as well. And with that, if I still have a little bit of time, I'll be happy to take some questions. Thanks. Yeah.
How do you think it took 3 years before you saw a significant response?
It didn't actually take 3 years. What we had was 2005, 2006 was data we collected prior to this event. In May 2007 is when we had that warming period, followed by what was actually a fairly predictable late frost. And then we came in basically a month and a half later and collected that last year's worth of data. But you're making a really good point, which is that this is the immediate effect. So clearly, when we're looking at this from a perspective of longevity, ideally we would have wanted to be out there this year. We would want to be out there probably for another year or two, and see if that is an effect that carries through some of the mechanisms that I kind of had on that next to the last slide. Avian productivity, predation, those sort of things, over winter survival of adults. That's really ideally, in the avian ecology world, those are that's your currency. It's all about productivity. Just the presence of individuals doesn't really tell you much that we have these species that are arriving on site. They're finding their habitat got nuked. Well, they're going to go over here into this refuge. That refuge isn't going to do them any good if that increased density that's happening in there is going to lead to increased predation. It's just going to be a smorgasbord for predators. It's not going to do you any good if that's going to end up in increased intra and interspecific competition. That's going to bring down productivity. It's going to reduce the number of young fledge. So that's ultimately kind of what we'd like to look at in order to really assess how significant and what the longevity of that disturbance actually is. But in terms of what you're talking about, is really just that last year that was the post-disturbance data. Yeah, Sam.
When did the birds arrive? And there's a 6-week period where there are no leaves. When did you start monitoring?
We did the monitoring.
Until you got the second one.
Yeah, we did the monitoring in early July, and that was sort of comparable to the previous year. The birds actually arrived in the area. It depends a little bit. Obviously, there's some variability every year, but they do arrive probably about the middle of June or so. And what they'll do is they'll be at the lower elevations. They kind of gauge what the conditions are, and it depends a little bit when that snowpack is completely gone, and then they'll start moving up into the aspen. So they kind of make do at the lower elevations, and once conditions are favorable, they'll move up. So we actually try to keep the time window fairly similar. By that time, of course, also the aspen that had not gotten affected because it had not started trying to put out that first leaf of flush during that late frost, that had fully leafed out. And those birds were in full gear. I mean, they were, the males were out, they were singing, so because that's ultimately what the census methodology relies on. It's just them being sort of in full gear. So it was basically comparable among the 3 years. It was those first couple of days of July as we were out there trying to. And that's quite a bit later than what a lot of people are used to. But we're dealing with fairly high elevations here, so there really isn't that level of activity until last week of June and first week of July.
Andy, thanks.
Yeah,
Appreciate
thanks.
it.